Okay, so isosceles and equilateral triangles is something you've been exposed to in the past, so this shouldn't be completely unfamiliar. So isosceles is when you have two congruent sides. And equilateral is when all three sides are congruent. Okay, let's look at some names on an isosceles triangle. So this is specifically an isosceles triangle. There's a lot of vocab here that will absolutely show up when we have a quiz or a test. So first of all, this angle right here. This is one of the two that are not congruent. So there's three angles and two are congruent, and this is the third angle. This is called the vertex angle. And so it is the angle that is formed by the legs of the triangle. Okay, the legs of the triangle are going to be the two congruent sides on an isosceles triangle. The ones that are congruent, they are called the legs of the triangle. So the two sides of the triangle that are congruent, those are called legs. So now the third side that's not part of the congruent ones, this one right here, it's not part of the congruent, and it's going to be called the base. So the base is the third side of the triangle that is not congruent to another side. It doesn't mean it has to be sitting on it. It could be rotated a different way. It's just the third side that's not congruent to another. Okay, and then last but not least, we have our legs. The vertex angle is between the two legs. The base is the third side that's not congruent. And so last but not least are these two angles right here. They are congruent, okay? They're always going to be in an isosceles triangle, two congruent sides and two congruent angles. These are called the base angles. And they're congruent, and they are formed by a leg and the base. So they are the two angles that are adjacent to the base, or that are formed by a leg and the base, and they're going to be congruent to each other. So the vertex angle is the third angle that's not congruent. The base angles are made between one leg and a base, and that's how you get a base angle. All right, so that vocab is going to be very important as we continue. Okay, so the base angles theorem basically says if two sides of a triangle are congruent, then the angles opposite them are congruent. So what that means is if you have these two sides are congruent right here, the angle opposite of this side is here, and the angle opposite of this one is here. Those are the base angles, and they are congruent. So that means you know that 7x plus 2 is equal to 8x minus 7. So that's using the base angles theorem. From there, it's just a basic algebra problem. So we're just going to solve for x. So we're going to get 2 equals x minus 7, and then add the 7 over. So you get x equals 9. All right, so then we still need to know y. Well, if you plug 9 back in, so if you come over here, 8 times 9 minus 7, use a calculator, that's 65 degrees. This should also be 65. It's a good way to check. 7 times 9 plus 2, use a calculator, 65 degrees. Okay, so both of those are congruent, which makes sense. That's good. So the third angle we can figure out because we know in a triangle, three angles add up and equal 180 degrees. So 65 plus 2y equals 180. So then we can just go ahead and solve for y using our algebra skills. Subtract the 130, you get 50, and divide by 2, and you get 25. All right, and so those would be, our answer for y would be y equals 25. And that would have solved x and y. We're going to skip example 2. I don't think anything of this is too complicated, so I'm going to go ahead and skip that one. Let's talk about the converse of the base angle theorem. So that's, remember, the converse is where you switch, you go backwards. So if two angles of a triangle are congruent, then the sides opposite of them are congruent. So this angle, the side opposite is this one, and the side opposite here is this side. Those two sides are congruent. That means 5x plus 7 is equal to 42. So we subtract the 7, we get 35, we divide by 5, and you get x equals 7. Okay, so over here on example 4, this side is opposite of that angle, and this side's opposite of this one. If the two angles are congruent, then those two legs are congruent. So you can do 8x plus 19 equals 12x plus 3. So then once again, it turns into just a basic algebra problem where you solve for x. So I'm going to subtract the 8x. 19 equals 4x plus 3. I'm going to subtract the 3. 16 equals 4x. And divide by 4. So you get 4 equals x, or x equals 4. All right, so the setup is the geometry portion. That's using your knowledge of the base angles theorem and the converse of the base angles theorem. After the setup, it turns into just an algebra problem that you already know. Okay, let's look at the corollary to the base angles theorem. This one is actually talking specifically about equilateral triangles. So basically, what this one's saying is if a triangle is equilateral, meaning all three sides are equal, then you know that it is equiangular. They go together. So if it's equilateral, you know it's equiangular. Now, if a triangle is equiangular, meaning all three angles are equal, then each angle equals 60 degrees. And that's because all three angles added together are 180. Well, if they're equal, you do 180 divided by 3 and you get 60. So basically, all of these are congruent because we know it's equilateral, so we know it's equiangular. So that means you can set each one equal to 60, and then you could solve. Now, to not make this Edpuzzle long, and because I know you guys are pretty good at solving, I have full confidence in you, we would divide by 4 and get 15. We would subtract the 25, and then we'd divide by 5, and we get 7. We'd add the 4 and divide by 32, and we'd get 2. So there's our answers for that. So the setup is the geometry part. The solving is really just algebra. Okay, last but not least, I want us to find the perimeter of the triangle. So the corollary to the converse is going backwards. Basically, if we know it is equiangular, meaning all three angles are equal, then we know it's equilateral. That goes both ways. So we know it's equiangular, so therefore, we know all three sides are equal. So that means 6x plus 16 is the same length as 9x minus 11. So let's go ahead and solve. Do your algebra process here. Add the 11. We get 27 equals 3x, divide by 3, so you get x equals 9. Now you're not quite done there because they wanted the perimeter. So if you plug in 9, 6 times 9 plus 16, use a calculator, it's 70. 9 times 9 minus 11 is 70. Okay, that's good because they were supposed to be congruent, so that's a good check for us. So this must also be 70. So the perimeter is where you add up all the sides. So 70 plus 70 plus 70, or 70 times 3, is 210 centimeters. And that's our answer. So really, the big key here is, what I would say you really need to know is, first of all, you need to know the vocab on an isosceles triangle. That would be very important for you to know for upcoming quizzes and tests and to be able to do these problems correctly. The next thing you know is that if you know two legs are congruent, it's isosceles, and therefore the base angles are congruent. The converse says if you know the base angles are congruent, then you know the two legs are congruent. The corollary says if it's equilateral, then it's equiangular. And the converse to the corollary, or the corollary to the converse, is if it's equiangular, then it's equilateral. And last but not least, when a triangle is equiangular, three angles are equal, each angle equals 60 degrees. So that's kind of the highlights of what we did today. So the setup is where you're using these facts, and then as long as you are good at solving, which I know you guys are because I taught most of you in Algebra 1, then you're going to be great at finding out what x is or the perimeter is or whatever the question asks you.